Hello, everyone. Going to do a review here of atoms and talk a little bit about the properties of water. All of this is being done in the context of biochemistry. Bio, of course, we know, I hope, by this point means life. Um, and of course, living things rely on chemistry, a lot of it. We're just going to start touching on it and some of the main molecules of it in this unit. Well, all of organic chemistry, org meaning living, and so organic chemistry referring to biochemistry or living chemistry, is predicated or based upon standard chemistry, right, or inorganic chemistry. So it's useful to know some of the basics about chemistry. And most of us have heard of these things, but you may have needed a refresher on some of the bonding types. So, atoms, I don't need to tell you what that is. I think most of you know that all matter, right, including that in living things, is made of um, atoms, right? And atoms themselves are made of three subatomic particles, right? Sub meaning below. And so protons, neutrons, and electrons. For our purposes, we mainly care about electrons because electrons are where the bonds are made, and electrons are really where chemistry happens. The bonds, or the breaking of bonds, the making of bonds is really where chemistry happens. And so that's the main thing we concern ourselves with. Some other definitions here that you can look up. So there's several different types of bonds, but the two main ones that we'll concern ourselves with are ionic bonds and covalent bonds. Ionic bonds have to do with when ions are created, and an ion by definition is an atom that has a positive or negative charge. Well, how does an atom become an ion? It has to do with its outer shell of electrons. Some of you maybe remember the terminology, the valence shell, right? In fact, that's where the term covalent comes from, right? The valence shell is the outer shell of electrons where bonding takes place. All the electrons inside of that are relatively stable. So if an atom like sodium, right, which only has one electron in its outer shell, really would like to be at 8, right, to sort of be comfortable with itself, right, to have that sort of outer shell filled properly, it's willing to give up, if you will, one of its electrons to other atoms that would like that electron to be able to fill their outer shell. Therefore, sodium and the atoms in the column that sodium is in tend to bond well with things like chloride and the atoms that chloride, the column that chloride is in. So really an ion is just a charged atom. When a sodium gives up one of its electrons, it still has the same number of protons, so now it has a net positive charge, right, making it a positive ion. When chloride takes on an electron, it still has the same number of protons. Now it has one more electron. Electrons being negatively charged make that whole atom now negatively charged, making it a negative ion. That's in fact what attracts those two together, making an ionic bond. Ionic bonds are not terribly strong. You can measure bond strength. They're not terribly strong bonds. The other type of bond that you need to be aware of are covalent bonds. And as I already indicated, valence means the outer shell, right? The valence shell of electrons. Co means, as you probably realize, together. So literally means putting together of valence shells. So in this case, electrons are being shared in that outer shell. Much of biology, much of biochemistry is going to be dealing with covalent bonds. Water being one of them. Okay, so why talk about water, right? There's lots of other molecules, lots of other compounds and atoms for that matter. But Water, of course, we know as living organisms, we're made up of a lot of it. And it plays all kinds of important roles in living things. So what is it about water, all right? What about its properties give it the characteristics that it has? Because it has some pretty unique ones. Okay, we probably know H2O, right? That it's made of two H's and an O, but what does that mean, right? So, okay, we've got a couple hydrogens and we have an oxygen. Now, hydrogen is a relatively small atom, oxygen a relatively large atom, and the way that these two things, when they're in proximity to each other, combine is in what is called a polar covalent bond. And we all know what a pole is, right? The North Pole, the South Pole, magnetic poles maybe. So opposites kind of. And polar bonds are really important. The reason this happens, right, is the oxygen would really like to have those electrons. And because it's the bigger atom, it tends to take on those atoms, giving that side of the molecule, the oxygen side of a water molecule, a slightly negative charge. Whereas the hydrogens that have given up their electrons largely, they share it, but not as often. They don't get as much access to the electrons, tend to then be slightly or partially positive. This property of water, this polarity, is what allows water to do so many unique things, right? Is what gives it all of its characteristics. So adhesion, sticking to something else, cohesion, sticking to other water, being the universal solvent, right, is what water is. All of this can be attributed back to the fact that water is polar. It has polar covalent bonds. So we had you answer some questions. How many bonds are in one molecule, water molecule? There are two bonds. Water molecules are very polar, so what does this mean? The oxygen atom has that negative charge as I talked about. The hydrogen atoms tend to have that positive charge. Excuse me. And because of this, again, many of these characteristics that make water so unique come from this. So it's cohesive, it's adhesive, it's very important in biological reactions. Okay, the final thing we had you do was post a picture, and this right here really is illustrating why polarity is important, right? Here's cohesion being shown, right? The slightly negative side of the oxygen here and the slightly positive side over here of the hydrogen attract each other and they form a really weak bond, but a form of a bond nevertheless, right? And this is what makes water cohesive, right? What leads to things like surface tension. And that has a lot of importance in how blood moves through the body and other sort of biological importance. Okay, that's all for now, and we'll see you next time.